Welcome to lecture 16 on risk management and insurance. In this lecture, we turn to the supply of insurance by insurance companies, and we show how they calculate the premiums that they charge to their customers. Now let's first do traditional premium calculation, and then later we also will discuss more modern approaches. Now, equation 1 gives the premium income of the insurance company. It consists of the fair premium income. So pi stands here for the fair premium income that covers just the expected loss. And lambda is a so-called safety loading that controls the risk of insolvency of the insurance company. So naturally, the insurance company must be able to cover the expected losses of their clients, but on top of it, we'll actually also charge a safety loading because those expected losses will fluctuate from year to year. We neglect administrative costs and monitoring expenses, and we assume that the planning horizon is 1 year. Now, the volume of insurance claims depends on the uncertain number of claims and the uncertain amount of each claim. So the insurance company does not know in advance, okay, how many claims there are in the year, and it does not know actually the size of those claims. Now, traditional premium calculation uses a loss distribution that ignores the timing of claims during the year. So in this traditional approach that we do first here, it does not matter whether the claim is in January or whether the claim is in July. We just look at the situation of an entire year. So loss distribution is skewed to the right. So we have here a positive skew because large losses may occur, but with a small probability. So that's the loss distribution. We have here the losses, and here we have the frequency of those losses, and it's skewed to the right. So actually, in this chapter, the loss is now a positive number. In the last chapter that we did, the loss was a negative number. And then actually, the loss distribution was skewed to the left. Now, I'm following actually the book of Zweifel, and sometimes there are changes like this in the book, which it's a bit confusing if you first read those chapters. Now, the equity capital of the insurance company equals the surplus of assets over liabilities. We invested quite a lot of time, okay, in this. We discussed the balance sheet of an insurance company, and in the balance sheet on the right side, okay, you have the equity capital. So it's a surplus of assets over liabilities. I just try to draw it here again. Oh yeah, okay. So remember a balance sheet. On the right side, you have all the assets. On the left side, you have all the assets. So here we have the assets. On the left, So on the left side, you have the assets. On the right side, you have the liabilities. And if the assets are bigger than the liabilities, okay, then we have positive equity capital. Now that surplus here of assets over liabilities, that belongs to the owners of the insurance company. Now, if it's a shareholding company, then it will belong to the shareholders. So the equity capital of an insurance company is the surplus of assets over liabilities. And we've invested really quite a lot of time, okay, to show that in an earlier chapter. Now, the available funds are the equity capital at the beginning of the year. That's this buffer stock, this equity capital, plus the premium income that the insurance company earns during the year. The premium income is paid by the people who have bought those insurance contracts. So the initial equity capital plus the premium income, that's really the amount of capital, the amount of funds that the insurance company has during the year. And if actually you have high losses, if the insurance company has to cover high losses during the year, if it faces high claims by its clients that exceed this amount of funds, then the insurance company is broke, then it's insolvent. So a large initial equity capital and the high safety loading reduce the likelihood of being broke, the likelihood of ruin. But the drawback is that if you have a large equity capital, okay, it's quite expensive to finance it. And if you have a high safety loading, then this drives up the insurance premium, and people will no longer buy the insurance. Remember, in equation 1, the premium income of the insurance company is the fair premium income plus the safety loading. Now, naturally, increasing the safety loading will reduce the probability of ruin, but the premiums are then actually increased. The premium income rises, okay, and okay, people no longer actually will buy the insurance. So the insurance company has a trade-off between safety and profitability. It can be very safe, but then actually it will not be very profitable because the equity capital, high equity capital is expensive, and a high safety loading, then the premium will be high, and okay, then actually it will lose customers. So there is a trade-off here between safety and profitability. Now let's do first the additional premium calculation with the number of claims uncertain and the amount of claim fixed. As an example, you can think of a whole, or so-called whole or universal life insurance policy, which provides you a fixed death benefit for some cohort of people. So everybody gets the same amount, okay, when they die. So that is certain. So the amount of the claim is fixed. Everybody gets the same amount, but we don't know how many people die. We don't know how many claims there will be. So the claims, the number of claims is uncertain. The total annual loss of the insurance company is just the number of claims, the number of dead people, times the fixed death benefit, okay, n times x. That's the amount of funds that the Liris insurance company will need per year. It has to cover those losses. Each person who dies, okay, then actually it has to pay, okay, X amount of X. And the fair premium income then is the expected loss. So a random variable is the N. You see, we don't know how many people die. Okay, the death benefit, that one is fixed. So the expectation goes here. And if you use now equation 1, remember in equation 1, the fair premium income times the loading gives you the premium, the total premium income. You can just plug this in for the fair premium income. So you have here En times X in equation 5. And now let's assume that the owners or of the insurance company, or maybe some regulatory agency, the government, that they require that the probability of ruin is less than a certain percentage, maybe less than 2%. So we should provide enough funds at the beginning of the year and earn during the year as premium income. So the probability of ruin, the probability is that it will run out of funds, that the equity capital will become negative, that this probability, let's say, is less than 2%. Then the probability that the insurance company will stay solvent will be at least maybe 98%. So in equation 6, we look at the probability that here we have the available funds, and here we have the losses, and this must stay positive. The available funds must exceed the losses. And the probability of this occurrence should be more than, let's say, 98%. So here that's against available funds. We had this from before. Remember equation 2. So available funds is just the capital at the beginning of the year plus the premium income during the year. The capital at the beginning of the year plus the premium income during the year. So that's the funds that we have in this year. So we have the losses here, which are the fixed death benefit. We look at this universal or whole life insurance policy. It's a technical term, universal or whole life insurance policy. It's a term that's used, okay, in the insurance literature. So that's the total losses, the death benefit times the stochastic number of people who die. You take the expectation, so you have now the expected fair premium income, and you could plug this in. Okay, here, so here we have the available funds, and those available funds must exceed the losses, and the probability of this, okay, should be, let's say, bigger than 98%. Now you can bring the ln here on the right side in this inequality, and then you can use ln is equal nx from before. Remember, ln is equal nx in equation 3. So write it like this. So it says exactly the same thing as equation 6. Okay, so available funds here, initial capital plus premium income, total premium income including the loading. This must be bigger than expected losses, or bigger than the losses. And the probability of that should be actually bigger than 98%. Okay. Now let's assume the premium income is given. So pi gamma is given. And then since equity capital is expensive, the insurance company will actually use a minimum amount of the capital to stay solvent with the required probability of, let's say, 98%. Then the inequality in equation 7 becomes an equality. So this inequality here will become an equality. Let's assume this premium income is given, and we will actually work with the minimum amount of equity capital. So there's really no reason to have here a surplus. Equity capital is expensive. So actually we work here now with an equality. And you can solve that one actually, for the required capital at the beginning of the year. So it will give us an actually the equation 7, so it will give us a required capital at the beginning of the year, which really guarantees us to stay solvent at 98% maybe. Now, in this equation 9, the death benefit X and the premium income are known. But the number of deaths is uncertain. But it can be determined by using a probability distribution. So the X is known, that's a fixed death benefit. By assumption, we know the premium income, and the N, the number of dead people, we can actually determine, by probability distribution. So let's go back to equation 7. So the premium income is known. The X is also known, and because we have equality, we can now calculate. This is determined by a probability distribution, the N, and then we actually can figure out this minimum amount of S that we need. We work then actually with an equality. So minimum amount of capital we need to stay solvent with a probability of at least 98%. Okay, next time I will do an example on this. So this was already the lecture of today. Thank you.